In this demo, we demonstrate how to make calcium sulfate models. Nanomaterial Modeler provides three types of calcium sulfates, differentiated by the hydration states: gypsum, hemihydrate, and anhydrate. We are going to build a gypsum slab model as an example. To start, select calcium sulfates, followed by gypsum. We provide two nanomaterial shapes for gypsum, box and wolf construction. In this demo, we choose the box shape. For wolf construction, please watch the video demo for wolf construction of gold nanoparticles or hydroxyapatite. Gypsum contains several different surfaces that can be defined by the Miller index. The Miller index is a notation for planes in a crystal lattice, and each Miller index has different planes and surface energies. Gypsum has the lowest surface energy in its 010 facet. Let's choose the 010 Miller index and put 50, 50, and 30 in X, Y, and Z to define the size of gypsum in angstroms. To generate a gypsum slab, select X and Y periodic dimensions. Please refer to the video demo for clay materials if you are not familiar with these options. We want to add solvent, so we leave the system type as solvated and click Next. We can check the generated structure by clicking View Structure. As shown in the previous tutorials, Nanomaterial Modeler provides two methods to adjust the water box size: specify water box size and fit water box size to material size. In this tutorial, we will solvate the gypsum slab with a 20 angstrom sodium chloride solution for both the top and bottom sides. Select the Fit Water Box Size to Material Size option and set the edge distance to 20 angstroms. In the Add Ions section, select NaCl in the drop-down menu. Note that you must recalculate the number of ions after making any change. After clicking the Calculate Number of Ions button, click the Next button to proceed. Now we can check the solvated system generated from the previous step by clicking View Structure. Note that the final system size may be slightly different from the initial values of 50, 50, and 70, since the system size is approximated by an integer multiple of the unit cell size. Click the Next button to proceed to the input generation step. In this step, select the simulation software you want to run your simulation. After checking the software, set the temperature for equilibration and production runs. Click the Next button in the bottom right to generate simulation inputs. After a few minutes, download all input and output files by clicking the Download button. You can check the files of all previous steps after decompressing the TGZ file and read a simulation example in the README file under each simulation software directory.